So, hello everyone, and thank you for joining this afternoon, and welcome to our May TDWI Australian Chapters webinar. Hope everyone can hear. So I'm Laura Profit, Managing Director of Business Minds, and it's a pleasure to have you join us from Sydney and Melbourne, and I know we've got a few international guests, so particular welcome to them as well. And I hope you enjoy your time here with us. I hope that you're all well, considering the current situation that we're all in, and thanks for the effort in joining this, because yeah, I'm sure we're all dealing with screen fatigue at the moment, so thanks for joining. This was supposed to be a physical event originally, but yeah, thanks to Kshira Saagar today, who has agreed to do this as a webinar. So we really appreciate that. So today's agenda is we will have our special guest, Kshira Saagar, Group Director of Data Science and Analytics at Global Fashion Group, and has the iconic online site as part of that. So thank you, Kshira. So I'll tell you a bit about TDWI. So TDWI, originally called the Data Warehouse Institute, now called Transforming Data with Intelligence. So the Australian chapter is the premier source for BI and analytics thought leadership in Australia. So this special interest group continues to attract a strong following from senior BI and analytics professionals in leadership, management and technical positions. TDWI Australia hosts regular member-focused technology meetings on a range of topics within the BI and analytics space. And it's very exciting that now we're able to include webinars for our chapter members and making it possible to share and learn from wherever you are. So we aim to use real-life examples from our member base or from vendors and delivery partners, and we strive to deliver proven thought leadership in helping technologists make informed decisions. And the TDWI members attract a wide range of professionals with vested interests in BI analytics themes, and we hope that if you haven't already, please join a physical meeting in the future. So before we start, just a little housekeeping. So we have put you on mute, but we want you to join the conversation. So throughout the meeting, please send your questions using the Q&A button at the top of the screen, and we'll address all questions at the end of the meeting. Also, the webinar will be recorded. So now coming to the main part of the meeting, so about our presenter, it's my pleasure to introduce Kshira Saagar, Group Director of Data Science and Analytics at Global Fashion Group. So that includes the iconic, it's a well-known online fashion site here in Australia. So Kshira has been with the analytics and decision sciences industry for more than a decade now, and having worked across the Americas, Asia, Europe, and more importantly, Australia. And the bulk of his work has been focused on developing solutions for the data science and analytics problem spaces of the retail, telecom and insurance marketing departments at some of the leading Fortune 100 companies. In his other roles, he's enabled decision making through data for clients from the media, healthcare, aviation, logistics and FMCG organizations. So he's a regular speaker at industry conferences and data summits across Australia and New Zealand, and has participated in close to 42 speaking engagements in the last 2 years. So thank you for attending, and we all welcome Kshira.
Thank you so much for having me, Laura, and the TDWI Institute. Thank you very much for having me. And I will probably, without wasting anyone's time, I'll try start presenting my screen. So let me know if you can see my screen, and then maybe I'll do a bit of a housekeeping on what it is and what isn't. Obviously, when I want to share it, it won't work. Yep. Yep. Can you see my screen? Hopefully.
Yep.
Can you all see my screen and see two of me? Not that as if one of me isn't enough. That's my
Yep.
test, and it's
Yep.
bright red in color. Cool. All right, cool. Thank you so much. My name is Kshira Saagar. It's spelled like this. The reason I put it out there is because I get confused, my parents get confused, everyone has fun naming me. So that's how it is. The K silent, like a knife or in a night, if you want to think about it. And I work for Global Fashion Group and The Iconic. Before I start, there are two things you have to know about me. One is I talk really, really fast because there's no filter between my mind and my mouth. And the second thing you need to know about me is I talk really fast. And that's what I said the first time. So if you didn't get it the first time, just I'm sorry, I talk really fast. I'll try to slow down. And usually when I talk in front of a live audience, I can gauge if somebody's falling asleep, trying to throw a tomato at me, going to throw a virtual egg at me. But unfortunately, fortunately, none of that is going to happen. But I'll just assume that all of that is not going to happen. If you have any questions, I will monitor the Q&A and then maybe we'll come to that in a bit. Cool. If you want these slides and if you find anything that I'm saying boring, you can just take a photo of the QR code. You'll have the entire set of slides on your phone or your laptop easily. The URL is also there for the set of slides, so it's publicly available. There's nothing secretive about it. And that's the extent of what I wanted to say. Cool. So I work for GFG, Global Fashion Group, which owns The Iconic, as Laura mentioned, in Australia, New Zealand, which is the largest clothing and fashion retailer in Australia, New Zealand. We own Zalora in Southeast Asia, Singapore, Malaysia, and a few other Indonesia, Philippines, Vietnam, Taiwan, and a few other countries. We own Duffy Tea in Latin American countries, Brazil, Argentina, Chile, Colombia, and La Moda in Russia, Kazakhstan, Belarus, and Ukraine, the Commonwealth of Independent States. So the Global Fashion Group owns iconic-like entities in 17 countries across the world, and all we do is pure play online fashion retail. And what I'm going to talk about today is how we approach data and what we use. How does Iconic and other similar iconic-like entities across the world use data? And that's what we're going to do. In the meanwhile, we have a huge sale going on, so go ahead and shop. You might get it tomorrow, so I really don't mind if I bore you and you start shopping immediately. Completely go for it, and I'm all for it. Cool. So the topic I'm going to talk about is how you can transform your whole company into one big data team. The common question that I keep getting asked by a lot of colleagues and people in the industry is, how do we start a data team and what does a data team look like? Who do we hire first and everything else? And my standard answer is, you don't need a data team. You need the whole company to become a data team. And so what does that journey look like? It sounds like a long shot and a big statement, but how do we approach that? And what are the aspects to it is something we're going to talk about. Cool. So, or in other words, basically, how do you stop thinking about data and actually start using it? Derived from the famous Peter Sellers book or the movie, How Do I Stop Worrying About the Bomb and Start Loving It? How do you stop thinking about using data and actually start using it is what you're going to talk about. So it's based on a true story. None of what I say can be made up. It's so good to be made up. Like I wish I had that kind of creativity. All of that, what I'm going to talk about is actually true. And so it might be interesting for people who've been through it, and it might be boring for people who've not been through it. So we'll go through that. So I'm sure a lot of you play the data pinball. So this is something I typically talk about. So data pinball starts like this. There's a team that's called the data team because they do data stuff. And so the data team, it is given the name because like it's a very broad umbrella term. So let's say in your company, you are in the marketing department or you're in some other departments, and you go to the data team and say, hey, you guys are called the data team and we think you can help us with this problem. Can you tell us what drove a particular campaign's performance in the last 3 weeks? A question like that. The data team turns out the data team is actually a data engineering team. And they're like, our job is to just make sure that the data is clean and collected, and we can't do the analysis for you. We can't do the drivers. Maybe you should talk to the BI team. So you walk up to the BI team and the BI team says, yep, we'd love to help you with the problem. But the issue is, we don't know exactly what you want to do. It is not about building a report. It's about doing the analysis, and there is an analytics team for it. Go talk to the analytics team. And then you trudge up, you go to the analytics team. The analytics team says, this is exactly what we wake up in the morning for. This is exactly what we want. But we don't have the right data for it. Can you go talk to the data team and make sure you give us the right data, and then they send you back to the data team. So the pinball happens all over again, and so people get pushed from one place to the next. And this is something that happened not only at the Iconic, but a few other GFG entities before we started rolling out this framework, which makes it feel like there's a lot of friction and a lack of credibility in the data teams themselves. With all the good intent that data teams have, the business does not trust them, or the business wants to go and get an external vendor coming in or stuff like that. So there's a lot of lack of trust and credibility. So how do you build that lack of trust and credibility is what we're going to talk about. Cool. So before we go into it, what I typically do is we talk about how do we explain what we do for a living, for data or data team or data science team. What do we do for a living? And the question that we ask of all our candidates is, how do you explain what a data team does to your 83-year-old grandma, right? So you don't have to use the words AI. You can't use the words BI. You can't use the words CI. You can't use the words MI, ML, AB, none of them, right? So how would you explain what you do for a living to your grandma? And so the reason we start from that is that's how we like to think about data. We like to think about it as something that's very democratic. Everybody can approach it and use it and doesn't have to be beyond terminologies. So the way we approach it is using a full stack. So what does that look like? So the way we explain it is think of data as a raw material. There's a lot of data available. There's so much raw material. Data is a new oil, or oil is a new data, however you want to think about it. There's a lot of data available in all the systems, in your transaction systems, in your CRM systems, in your marketing systems, in your other like clickstream data, you can name it, and you have data accounting systems. So there's data in so many places, but what somebody has to do is make an effort to get all of that data out of those systems into a place that somebody can see. So think of oil buried deep under the earth, and data is buried deep under all these systems, and somebody has to build a pipeline to get the oil all the way up. And a lot of what we do with data is in terms of data engineering, as we call it, or data warehousing, as we call it, is getting that data out of these systems, cleaning them up, putting them up in places where you can actually use them. Once you've brought the oil back up into the earth, then what happens next is somebody has to make petrol out of that oil. So you'll have to apply some chemical process to it. You'll have to clean it. You'll have to transform it. You'll have to do some magic to it. And then eventually what happens is oil becomes into usable form. And there are a lot of byproducts like soap and stuff like that. So similarly, just collecting data and just keeping them is not what it is all about. I've had the good fortune of working with companies where people got excited collecting data, but didn't want anyone to use it. So it was locked away in a data warehouse somewhere, or in a dashboard or a database somewhere, and nobody could touch it. And if you can't use the oil, there's no point in drilling it and collecting it. Similarly, if you can't transform the data into something, there's no point in doing it. So that's the petrol making process. And it's not just good enough to make petrol. You'll have to actually showcase the value of petrol. So you could have the best petroleum extraction process, but if you can't market it well, if you can't sell it well, and if you can't talk to the users or the customers about it, then there's no point in generating that petroleum. It's as good as not even drilling the earth. So a lot of times the issue we have with taking data to the business and getting the business to start thinking about it as their own is there's a huge barrier between math and English. So people either don't have numerical literacy, or don't want to appreciate data, or data inferential skills are much hard to come by. So how do we break that barrier, and how do we get everybody in the business to appreciate the value of data as something that we do? So then you can move forward. Just like you can take oil and move forward, you can take data and start making decisions. And that happens through a 3-stage process, which is data engineering, which is basically all pipelines, data science, which is applying intelligence at scale simply, and data translation, which is what we call showcasing the value of what we do. So this is the typical view that we look, and the way we've approached it is we don't think of them as 3 different functions, and that's why you'll not hear me use these 3 terms anymore. We don't use the word data engineering, data science, data translation in the sense that they are. We just call the whole team a data team or data science team, for the simple fact that we like to think everybody in that team is able to do all of these functions in one go. So we call that the full stack data scientist. So a full stack data scientist is someone who, if she can come in, she can get the data herself, she can build the algorithms herself, and she can actually take it to the business, and she can make the business believe that this is the right thing to do. And that's a full stack data scientist for us. It's not necessarily a hard thing to come by. We don't expect everyone to know all 3 areas of the business, all 3 areas of the pipeline, but we expect them to know some aspects of it, and then we have people who can help them and develop that skill. So this is what I call basically the data set, mindset, and skill set approach. So a data set is basically how do you fix the data engineering part of it. skill set is how do you fix the data science part of it, and the mindset is how do you fix the translating that insights into action part of it. So this is we instead of calling it engineering science and translation, we just call it data set, skill set, mindset. And we'll just cover a couple of examples in each of these parts on what we've done and concrete examples of how we've taken that. Cool. So the problem with data set is a lot of us have been in meetings on either side of, if you're from the data team, you've always been frustrated with somebody asking you, what is the actual sales for the day? What is the actual new customers for the day? What is the actual, how many products do we actually sell? And you might have one answer. Somebody from a different team might have a different answer, and somebody might look at a different system that you don't even know that exists, and that's a different answer. So there are so many disparate data sources, and that stops, and that's a lot of frustration. A lot of time spent on reconciling data, matching numbers. There's people have entire occupations where they're matching numbers from one system to the other, and what that causes is, one, it makes you lose the credibility of what data can do, and the second and the biggest problem is there's a lot of friction in actually making that information. So how do we break that barrier? We will, again, like a lot of things that we do, we don't use terminologies like single source of truth, we don't use single customer, we don't use any of those things, because not because they are not because we don't believe in them, but because we want to do everything from a first principle idea and fundamental principle thinking. So how did we break this barrier is, so okay, so let me just come to it. So how did we break that barrier is what I'm going to talk about. We have two separate examples of how we've broken that data set barrier, right? So one is the feature and metric library, and I'll come into it that a bit. So that is something that addresses this disparate data sources issue for the entire business. So the whole business can stop worrying about which metric is the right metric, and we do that using feature and metric library. But the second problem is, once you start centralizing things a lot, like building feature libraries and metric libraries, what you're trying to do is you're trying to add a lot of friction getting newer and newer data sources in. So this could be the engineering team, this could be the external vendors who help supporting you, this could be third-party platforms. So how do you build a platform where you don't limit the volume of data coming in and you facilitate more data coming in, at the same time actually validating that even in a smarter way? So that's what we call the smart endpoint dump button. And so I'll cover both of these topics, and if you have any specific questions on them, I'm happy to talk about them at the end. So what is a feature or a metric library? People who are in the data science space and the data engineering space know what a feature library is. We typically build a feature library, which is all the information available about a particular aspect of a business. So let's take an example. A customer feature library is just at a customer ID level, every single piece of information about that customer in all the systems. So how much did that customer buy? When did she come? What platforms does she use? What brands does she buy? What day of the week does she shop? What kind of delivery does she like? And what kind of colors does she like? What kind of design patterns does she like? So if you can think of a customer, and if you want to ask, say, 800 odd questions about that customer, every single piece of information about that customer from multiple systems. It could be your transaction systems, your CRM systems, your marketing systems. How many times does she see a Facebook ad? How many times is she likely to open an email? So everything about a customer is all collated together, and we build a feature library for a customer. Similarly, we build feature libraries for a product. This product, who buys this product? What is the age group for this product? How often does it sell? What does it typically sell with? What is the price point it sells at? What markdown does it sell at? Everything about that product. Similarly, everything about a city, everything about a marketing channel. So we build feature libraries like this. And what that does is, yes, normalizing data is really important. Yes, trying to put it in proper format is important for analysis. But the moment we start normalizing things a lot, what tends to happen is we tend to have multiple tables that are stored away in a data warehouse somewhere, and people have to know a language to use the table, or need to have an expensive software to put on top of that to use the table. So what we try to do is we build feature and metric libraries, which are just simple JSON objects stored as schema-less objects in BigQuery. And so anybody can just come in and then just pick a particular customer, and all the information about that customer can show up in a dashboard just by pointing and clicking. So that's something that we built that massively changed how people found information. More often than not, people wanted to know the same information. At a day level, give me all the information. At a customer level, give me all the information. At a brand level, give me all this information. And these metric libraries are available for anyone to come, point and click and get that information at a shot. And these are living objects, just like corals are living objects in the sea. So what that does is people can actually keep adding to these feature libraries. So when data scientists do newer algorithms, build on newer things, they can add a new feature to this customer thing. So we have around 863 odd features for every single customer, and they keep getting appended more and more as and when people have a new thought or a new idea, or when somebody has a new idea to add, so it keeps getting added, so it keeps getting expanded. So this is one way where instead of somebody having to go to 5 different systems to get information about a customer, they just come to this feature library because they get a lot of information here. And because they come to one place, there is also a lot of, there's the issue with reconciling data and trying to find out different numbers in different platforms or something. So that is one way we've solved the problem. So an example is, like I said, a customer feature library. We have 865 odd unique metrics at a customer level. And so different regions have different volumes of features. And then at a group level, we have all the information about a customer at a wider level. And that's something that we use. The second problem is, like I said, is the problem of where once you try to formalize and standardize things, you might end up blocking people. And if you remember the stack view that we spoke about, we don't have a data engineering function, not because, like I said, we don't want to, again, break down how we approach data into different parts. So without a data engineering function and with too many microservices being built at the Iconic and other GFG entities. So at the Iconic, every single function on the website, like if you like something, if you wishlist something, if you order something, if you look for a delivery, every single thing is a separate microservice. So every single microservice has its own database, its own data coming through. All the real-time systems that are everywhere are all microservices. So we would probably need 70 data engineers or 35 data engineers if one data engineer picks 2 microservices to spend time getting the data coming into a platform. So we didn't want to do that because everything was in a microservices architecture and we wanted data to come in real time. It could be through our internal engineers or it could be through our third-party platforms. What we built was a streaming pipeline. We call it the smart endpoint and dump pipeline, because what we did was we built a dump pipeline. This is the best I could do for pipeline. So you have to put up with it. Could be an oil pipeline. So we built a dump pipeline. And what the pipeline does is it just gives, there's a standard format in which the input can come. And the input has to be in a particular format. It could be the app ID, what is the message body for it, which is a JSON blob, and then any other piece of information. Was it retried? Was it the actual message? When was it sent? And then that gets just dumped in to this endpoint, where in this endpoint, that schema is then expanded, or it's let schema less, or it's just dumped directly into BigQuery table. And so what that does is, this acts as a data engineer, and anybody who's an engineer or a software engineer or a front-end developer or a back-end developer or a third party can directly push information from this platform in a particular message body format, which is standardized, and then it starts coming into it. So what this has done is it's massively lifted the amount of workload that our data engineers would have done, or anybody in the data team would have done, and everybody can start pushing data into a platform. And then this platform will then start being connected to what I will come to next, and people can immediately see this information. So this massively undercuts the amount of time involved in collecting new data sources and therefore making faster decisions, and therefore not having to wait or go to a different platform. Everything happens in one platform, which is what I'll come to next. So how did we solve the data problem again? We built feature libraries and we built smart endpoint and dump pipelines. Like I said, let computers do what they do best instead of having human beings do data engineering jobs. And so how did we measure the success of something like this? Is instead of having structured databases, we have amorphous data sources. This data source could not just be information that we see at the Iconic and other entities. We have a lot of visual similarity based algorithms going on. And for all of them, we need images of all the fashion products. So it's all images. Then we have text-based analytics going on. We have a lot of ratings and reviews going on. So a lot of descriptions of products, a lot of description about customer feedback. So we don't just have text and numbers. We also have images, we have audio, we have other pieces of information. And all of that feeds in real time into this platform. Cool. So once we somehow filled the data set problem, then the next problem is the skill set problem, the problem of bridging the tool and skill gap. So let's say magically somehow I've gotten all the data in one place. I've built feature libraries. I've built smart endpoints and dump pipelines where people can start pushing data fast without having to wait for data engineers. The next big problem is the problem of how do I now access this data? Because all of this data is coming through. It's all in a database somewhere. It's all somewhere. How do I access it? Like if I can't access it, like I said, it's completely useless. If I can't turn that into something, it's completely useless. So how do I do this? So the comic that I like a lot is the way we hire these days is there's a lot of mismatch with skill set. So our ideal candidate, the interviewer says, would have a skill set that applies to at least 3 areas that don't exist yet. So we are no longer hiring people for what they know, is we're hiring for people what they should know in 6 months time. So how do you can't the skill set problem can't be solved by just getting people who already have those on their resume. It can only be solved by building tools that enable these people to learn them much faster. So how did we do that? So we did two things, and again, like two examples of things that we've done to break the skill set issue. One is we have single unified reporting. I'll come to that in a bit. And the second one that we did is we have a federated structure to data. So we don't have a centralized data structure. We don't have an uncentralized data structure. We have a federated structure. So I'll come to both of these things in a bit. Again, both of them solve two different problems. So single unified reporting solves the problem of the business to get information really fast. And the federated data structure helps the data team to work with the business in a more unified and in a much easier fashion without having to be caught up by politics or any other stuff. So what is single unified reporting? Everything at the Iconic and also a few other, and even at GFG and a few other GFG entities, and is all directly, there's only one reporting platform. We preferably kind of killed off all the other reporting platforms and just have one reporting platform, which is called Superset, which is an open source application. And the Superset dashboards can have your buying tools, it can have your operational dashboards, it can have your marketing performance dashboard, it can have your finance dashboards, it can have production reports, it can have even PNC dashboards and everything else. So we have everything sitting in one place. And the way to think about it is, instead of solidifying and instead of trying to bring multiple data sources in one place, what we try to do is we let data sources stay where they are. We try to build multiple feature libraries based on the technologies that are best available at that point in time. But all of these multiple data sources, internal, external, feature libraries, whatever it is, all of them are only accessible from this one platform. So it's almost like the Lord of the Rings style, where one ring binds them all and one ring rules them in darkness, but this is hopefully in light. So this one ring, this one platform is the entry point for everybody in the company to get access to data. And therefore, there is no way where they can get confused by saying, I looked at this number in this particular tool in this platform, and that's at 100, that's at 20. There's only one platform to get information, and that platform needs to have the right information. Therefore, there's more onus on the data team to provide the right information. So all the reports are available for everyone in the business to see, except for profit level metrics. Everybody in the business who has an email ID can log in, can see all the numbers for everyone else. And that massively supercharges how people approach a problem. So they come in the morning, they open up a dashboard, it immediately tells them what happened yesterday, what is happening right now, what you should be doing tomorrow. So that makes your job much easier. So you don't have to think through all of those things. You can think about other things to solve. And that kind of takes away the problem of having to do the mundane, boring stuff again and again. So I call it the Costco of dashboards, because it has, you'll find some very random stuff in there. So somebody would have asked a question, somebody would have answered that question and the dashboard for that. And so there's a common running joke that if you have a question, there's a dashboard for that. So any question you have, there's a dashboard for that. So somebody would have built it. And also it's not just continuously building it and filing it and leaving it there. I think the team also does a 6-monthly, yearly effort where they go through all the dashboards, look at what is useful, what is more accurate, what needs to be killed, what needs to be modified, and that's an effort that happens in the background quietly, so that we only have cleaner, more useful dashboards that are available at any point in time. A quick stat: so the platform that we built at the Iconic in the last 4 weeks just had 2.5 million unique views of all the reports across the business. So 2.5 million unique views, not of the website, but just of the dashboards that we built. So that's how much people at the Iconic use these dashboards and to make decisions. Cool. And the federated data republic is the part where instead of locating people in a centralized data team, which would have meant there's somebody like me, a blocker who has to filter all the requests through and then have workforce management, or a very decentralized setup where everybody worked in different business areas and nobody spoke to each other, which would have cost, because the same person would have solved the same problem multiple times in different areas. What we have is a federated structure, which means the data team, everybody in the data team sits in a cross function of data, and they have a practice leader, they have somebody who guides their career, who tells them what to do, but we also have them working individually in the unique business area, where they work with them for 3 to 6 months based on the problems they have, and they work exclusively for them. They sit with them, they ideate with them, they brainstorm with them, they understand what problems need to be solved. And so what that does is the business gets somebody exclusive for them, think of them as a consulting engagement, and the team also gets common knowledge, common wisdom, and common technical expertise by being part of a common group of data scientists. So that kind of a federated setup has helped us solve a lot of problems at scale. So instead of saying, no, these 4 people are busy only solving these one area of problems, there's one person in each of the 4 areas. And if they need more people to solve these problems, then they need to invest more into data and the people, and they'll get more people. So that way, they also appreciate that this problem takes so much effort, and therefore we need more people to solve this problem. So that's something that we've done. And the data, it's not just the data people in these squads. We also have developers from whom we learn. We have UX people, we have platforms engineers. So all of these people work towards a goal, and that makes it really easy for us to deliver on the promise that we had. Again, so the skill set problem is the problem of where somebody passes the buck saying, this is not my area, I can't do it. So we stop the game of passing the buck by either having a platform where all the dashboards are available in one place. And then the other way of solving that problem is where we have everybody just working together in a cross function. Therefore, they don't have a lack of an expertise to help them solve a particular problem. So that's how we solve the skill set breakdown. So somehow, how do we measure the skill set disparity? Is if you have La-La Lands, as I call them. So La-La Lands are simple, listen always and learn always things. So the common joke goes that the one thing that my CEO says a lot is every year we have Christmas coming on the 25th of December. And what that means is we all know when Christmas is going to come up, but every year we try to do the same analysis again and again, answer the same questions again and again, try to understand what should we do for this Christmas. And when Christmas is done, how did we perform in Christmas? What should we change? So we're trying to answer the same questions again and again. So what a listen always, learn always does is somebody solved a question once. It could be an optimization problem. It could be a driver analysis. It could be a simple prediction thing. Just put it in a simple microservice or a nano service or whatever you want to, and then let it just keep running and let's just fetch the data, let's run the algorithm or the drivers analysis or whatever you're trying to find out, and it will come up with an output, and you just keep looking at it. So just have something that runs this continuously. And if the microservice finds something interesting, it can send us an email and let us know that, okay, something interesting has come out, and then therefore we can look at it. So if you solve a problem once, just solve it once really well, and then just let it be and let it listen and learn always is something that we look at. And then once you solve that problem, then the last problem of once you solve the data set problem and once you solve the skill set problem, then you have the problem of the mindset. And mindset is how you approach data. What do you think about data? And the biggest taboo that data is a technical area that you need to be a unicorn with wings and horns and stuff like that. How do we break that myth? Is what you're going to talk about. Typically, companies approach it by let's first fix the mindset that we're a data-driven company. Then let's buy the tools, and then we'll get worry about the data. We do it the exact other way. We said let's fix the data first. Let's get credibility in what we do. Let's provide the data to the right people, and then let's then try to change their mindset and attitude, because that's the right way that we think works really well. Okay, so what does that include? There are 2 parts to it when you say we remove the cultural bias at data set tech area. One is we have data teams. Again, like there are 2 different areas that we cater to. One is the wider business, because we want to make sure that everybody, and we'll come to what that everybody needs to have in the business. And the next part is if you have a fast growing data team, and the biggest challenge obviously is finding really smart people like you who can come in and work for the data team and who can just quickly build the team. So how do we quickly build the team, and how do we break the mindset that data team needs to only have these kind of people? So those are the 2 things I'll cover. So data T stands for tools, education, and access. By now you realize that I love my acronyms. There are only 2 kinds of people when it comes to acronyms. One is somebody who can create an acronym, and one who can't create an acronym. So also the other way around, I messed the joke up. So it's tools, education, and access. And so with tools, education, and access, what we like to believe is we should build tools that everybody in the business can get access to. Either you're a company with deep pockets that can get everybody the same tool that everyone else in the company has, or you can build open source tools that everybody in the company can have for free. So you have to build the right tools, and that's something like we spoke about in single unified reporting entity or in the smart endpoint dump pipeline. We build tools that everybody can get access to without any restrictions or any commercial liabilities. And the next part is the access. So the access is where we give them the right access to the right tables, the right databases, the right metrics, in the right format. This is done as part of a data governance effort, and I'll probably not go too deep into it, but we have 5 stars level of access for everyone. There's a 5-star person who can access everything. Then there's a 4-star person who can access some things, and so on and so on and so on and so on. So basically based on their roles and responsibilities and their current job designation, they can access the right things in the business the day they join. And that leaves the last part, which is education. And what we do is we do two kinds of education. One is educating people on what data we actually track. Think of it more as an awareness thing. So data awareness sessions happen where we tell people, okay, these are the things that we track. We track what people buy on site. We track people, how they buy. We track what they do on their app. We track where they come from. We track what they say. And so people who work in the data and tech area assume that it's common knowledge that everybody knows what is tracked. But whenever I've spoken about this to business users, it's a light bulb moment for them to say, oh, I didn't realize that we could track that information, or we have that information. Can you answer this question for me? So we do a lot of data awareness sessions. And the other thing that we also do is we also have a proper uni style syllabus where we have a SQL sessions for people who want to learn SQL, and we use our existing databases, we use our existing metric libraries, and we teach people using our existing tools how to write SQL to get that data. So the platforms we have also let you write SQL. So we teach people to write SQL on the data that they need to use. And therefore, they don't learn any other SQL. They learn SQL that they need to use on a day-to-day basis. We also have sessions where we do Python. We have then people who are small focus groups who learn TensorFlow. And so depending on people's interests and requirements, we also do courses in-house where people can learn all of these things. And I think that is also another thing that helps people break that mindset that this is something I don't want to know versus I want to really be a part of this discussion. Tell me more about it, and how do I also start using it? And so we've had people, some successful use cases where people in marketing actually write Jupyter notebooks and write Python on them and do their own analysis. We've had people from finance who moved into data to become data scientists. We've had people from different software engineering and other areas move into the business because they like what they see, they like the tools, and they want to contribute. So that's something that's happened a lot. So our culture is, if you want something, you build it and you own it. And so that only happens if they have the right tools, the right education, the right access. So instead of having true self-serve dashboards or true self-serve data tools, we want to make true self-service decision making. So you want to be able to make the whole decision from a self-service point of view, and not have to be dependent on anyone. And then finally, we have a framework. I like to call that the framework, the AAA LST framework. So instead of thinking of problems as ML problems, AI problems, dashboard problems, boring problems, it's not how we think of problems. It's just the problem that needs to be solved. And the framework is on a AAA LST framework, which is this a problem that needs to be automated, which means somebody has to never do that again. It's completely automated. Should it be augmented, which means will somebody have to make a human decision at the end of this process, which is some automation, but human being has to make a decision. So it's a dashboard where somebody has to press a button to make a decision, and then applying it. Think of it as computer vision problems where you can't automate. You're not only automating it, you're completely applying that problem at scale. So based on the kind of area, we have three areas of problem: automating problems, augmenting problems, and applying answers. And it's not cut out like that, but we have three different kinds of problems that we solve to, which is, are we learning something about it? Are we solving for something? Are we going to do something? So an example of automating learning is what we call building dashboards for retrospective campaigns. So we've run a campaign for Christmas. We want to run the same campaign next year. We've automated that learning. We have a driver analysis for that. It's all completely automated. The next time something happens for Christmas, the numbers at the press of a button, somebody will have all the numbers. So they don't have to do the learning again. So it's automated. Augmenting solving. I think of the solving as a problem where you have to solve for X. So X is how many units of item should I buy? So this is a problem that a buyer has. How many units of particular brand or a sweatshirt should I buy? So she knows what she needs to buy, and all she needs is the right tools and the right platforms that augment her decision making. So we automate what is the last 52-week process, what does the demand look like, how many customers came to the site, blah, blah, blah. And then there's a score that says you need to buy 15 units. And then she can augment it by saying yes, no, buy more, buy less. And so that makes it really easy. And so that's an example of augmenting solving. And think of doing as making recommendations for customers, right? So doing is making recommendations for customers, giving customers delivery estimates. These are things that you do. And so you can automate some of them, but sometimes it's beyond automating it. You have to apply that at scale. So you might have to employ computer vision. You might have to employ different techniques to solve that problem. And that's what we call applied doing. And so if any problem comes in, we try to put it in one of these 9 boxes and say, what kind of a problem is this? And who has the right skill set to solve these problems? So Somebody who's really good at doing data ops and DevOps is really good at, say, doing automating some of these things. But somebody who's more of a data scientist, comes to the research background, is somebody who's really good at doing application problems. So we figure out what the problem is and then try to solve the problem. And so that changes the mindset of, okay, this is a very tough problem to solve. People start talking about it in these terms. So finally, when we needed to hire a lot more people, what we did was I'm a strong believer in TDWI, which says anyone can cook. We believe anyone can data science. So what we do is we inner recruit. So like I said, we've recruited people from marketing to be in data science. We've recruited people from finance to be in data science, from software engineering to be in data science, even from vendor management to be in data science. So from across the business, if somebody wants to come and join the team, all they have to do is be able to write code, be logical, and be willing to unlearn things and not come with a bias, and then we bring them in. And our motto is Avia Pervia, which is the motto of an Italian city, which means making complicated look simple. All we want to do is give everyone the freedom that the complicated things look very simple. Don't worry about it. We can solve this problem, and anybody can do data science. And that's the approach we take. So how do we measure if we've done the right thing and the mindset of data being a separate area is cured? If we don't have one data team for the company, but if the whole company is a data team, and when everyone thinks we are all data driven, I think that's when that mindset problem is solved. And I wouldn't say any company has completely solved it. Even we are on a journey, we're trying to solve it. Some areas of the business feel more data driven, some don't. And so it's a process we're trying to do area by area. So that's pretty much what I had. And so whenever it comes to all of this and somebody says all of this looks really complicated, we just don't want to do it, and I typically aim this at business users who say, I'm an executive, I don't have time for all of this. What's the worst that can happen? There's a 50-50 chance something works or doesn't work. I tell them there's a 50-50-90 axiom. If you trust in the 50-50 thing, 90% of the times you're going to be wrong. Don't ask proof for this. It's an axiom, so you can just use this. You can attribute to someone else, like typically attribute to, say, who's the most famous, an Oscar Wilde or Winston Churchill or Mahatma Gandhi or someone. I've never been able to find out who the actual person is, but you can attribute to someone, but it works. Finally, again, this is all I had today. We talked about how we cured the data set, how we cured a problem of people thinking about data as a company-wide initiative through a data set, skill set, and mindset approach. You can get the slides here on this URL. If you have any feedback for me, you can leave feedback for me on my side. You can get the application, you can get the slides by scanning this URL code. So that's me. And I will now open up for a Q&A. So if you want to give Q&A, all you have to do is you have a Q&A button there. Just go in. I already have 3 questions there. And I'll stop sharing my screen, or I'll leave it at this screen so that you can all go and join the TDWI Institute. Thank you for having me. And then we'll probably go to the questions now.
Okay, so thank you very much, Kshira. That's very interesting. And I think it's got people, quite interested to understand some of the things. So, I suppose one question I have from Tim is, with all this data and so on, how and different people. If different people require different views of the data, does it get unruly with so much information, and who decides how new stuff is added?
Sure. Okay, so the first part is the unruly part. So the unruly part, the problem is, like I mentioned, we do a lot of culling of the information regularly. So we do our own culling. So we track exactly how many times the dashboard is viewed, who uses them, what is it used for, how accurate the numbers are. So we don't let any wild west numbers and metrics float around. So that's something we do. And we kill completely dashboards that have not been used for a certain period of time. So that's something that we do without it becoming a weed garden. How do we make sure that different people get different views of data? What we do is everything is, again, the final output of the dashboards is all, final output of the reports is all provided as in simple tabulated formats. And what somebody can do is then explore that chart or explore that visualization and then filter for what they need. And so instead of building, say, 10 dashboards for different areas in the marketing department, we build one dashboard. And then everybody in marketing can filter for their particular channel and get all kinds of metrics that they want. They can ignore the ones they don't want to, but they can get everything in one place. So instead of building 10 views of the report, we just build one view, and the data source behind it has all that levels of detail, and that makes sure that we don't build the same thing. There's not 15 same looking charts in 15 places. It's just one chart with the right amount of filtering and slicing and dicing going on. To the second question of who decides when new stuff is added, can anyone add it or only some people can add it? The business obviously decides who wants to add a new dashboard or a new metric. It's decided with the business. They say, we think we want to start tracking this going forward. So they come up with the request. And then only certain people in the data team can add these new dashboards. And therefore, it is again not the Wild West where everyone can add a dashboard. But what the business can do is explore the dashboard and not save it or not do anything with it. They can play with it how much ever they want, but they just can't save it or overwrite it. And what that provides is only one entry point for these things to come through. And then people can then explore it and play with it however they want. So that's how we make sure that this doesn't happen.
Okay, thank you. Next one from Stephen. So in terms of data education, so he's asking, I suppose, does it encourage business users to, because it does encourage business users to get down and dirty with data, does that soak up too much of their time, just because he sees that's been a problem in his experience?
So with the down and dirty, I get. So with the down and dirty part of the data, the biggest problem is a lack of awareness of the information. And what we do is we structure it and we make sure that the commitment from the business is also there. So the one thing we don't do is none of this is highfalutin, oh, we want to do a session and then everyone gets excited for the first week and never comes back. If people want data education and want to be part of it, they need to dedicate, and their managers need to make sure that they dedicate, say, 2 hours a week for 4 weeks or something like that. And they're also given assignments, so they make sure that they actually start using it on a regular basis. And with the tools we have, because by design, these tools don't let you get drawn into random stuff. Like all of the data sets are labeled, all the metrics are labeled. So what that does is when they come in and when they start using it, they know exactly what they're looking at and how these metrics are defined. With the SQL sessions, we made a decision to teach people only SQL, only using our databases, because what we found out was people would go out and do these online courses on SQL, which is really good, but they would go away and do a course somewhere else, and it would say select star from something, 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 and they're like, this exactly doesn't work here. And because they probably learned, say, PostgreSQL, and you have an Oracle database, or they learned Oracle PL SQL and you have a Postgres database, or they learned BigQuery. So people, that for somebody who's starting the journey, it's such a hard thing for them to do. So what we show them is, this is the platform, this is the only SQL you need to learn, and so this is the table that you need. And what will you want to do? You want to just understand how much people bought in a particular brand, blah, blah, blah. This is the query and this is how you write. And so we also teach them the grammar of SQL. So I kind of make it really painful by telling them what is a verb, adverb, pronoun, adjective, and sometimes people like, we never like, people don't know what an adverb is, which is funny. And so they had to learn what an adverb is from me, who I don't even speak English as the first language, but, and so then we do this stuff. And so that, I think that definitely works. And I saw a lot of traction for that. And I think one thing definitely, if we want to get people on the journey, is somebody has to put in the effort. And luckily we had the luxury and the effort to put that time in. And so that definitely works.
Okay. And a question from me is, do you find that certain people really embrace that kind of involvement, and are there some people who don't?
Yeah, definitely, right. And so the only people, because our filtering condition automatically is people who are willing to commit 2 hours a week for 4 weeks and they should come, that automatically winnows away a lot of people who just had a fleeting interest in it. What we've noticed is these are people who are like, I'm just tired of waiting for someone to tell me how to do it. I just would want to do it myself. And so they already have that intent. And if we just enable that a little bit more, it's amazing. It's magical. So that definitely works.
Okay, no, that's a good story. From Hannah, so what are good examples of augment and solve? It's just that it wasn't quite clear.
Good. So augmenting is a very a blunt and honest way of putting augmenting is problems where you don't want to replace someone. So I cannot walk into my warehouse and say, I've solved this problem somehow. Just just trust the algorithm, right? So it could be rostering, it could be assortment optimization, it could be replenishment of your stock. These are things an algorithm can technically do, it can technically do, but what that does implies is your algorithm is really fast, which cannot be the case because human beings have more context of the business. They can understand market movements, they can understand what's happening to a brand, they can read social media, they can see a lot of things. They know what a person's for example, let's take the example of rostering. Instead of an algorithm completely rostering it, what we do is we provide a rostering tool which augments, which gives you almost all the decisions that need to be made. You need 25 people to come in today. You need, out of these 25 people, 5 of them are in this area picking, 6 of them are in packing, blah, blah, blah. But then the supervisor finally gets to make the decision saying, I don't think this is right. I want to override it. I want to make something else. So we're augmenting that decision making. And what we are solving is basically trying to find out what the answer needs to be. How many people do we need? How many units do we need? And so instead of completely automating away those problems, we enable them to a point where a human being augments that final decision by having the overriding power. So think of it as a nuclear button. Somebody can override it finally through keys, and that's technically what we provide.
Okay, thank you. And next question is, how did you get senior management to agree to your strategy of data for everyone?
I think it's the other way around. The senior management had the idea that everyone should have data. So it came from the top saying, do something, but everyone needs to have data. And that's like, oh, it's really match made in heaven. So I really want to do it. They want to do it. So it worked out fine. I know that there are areas where people don't believe in it. And for them, it's more about a credibility journey. So what I advise people is try to bring in the credibility into data, show them what is the value in it. And it's going to be a painful process, but at least in our instance, it was really easy. The senior management was the one that pushed us to go for it.
Okay, no, that's interesting. That's good. So a related question is, are data initiatives centrally funded, or do you have to go to individual business units to get funding?
So it's a mix of both. As a group, as a tech area and data area, we have a specific budget for the year, and we plan how many people we need based on our workload. But what also ends up happening is, like I said, because people work exclusively with the area. Say, for example, marketing, the CMO might say, I really need to solve this problem. Why don't you take 2 of my resources and you get data people for it? So that also happens. So it's a mix of both based on the urgency of the situation. The CMO, the CEO might say, yeah, take my resources, take my budget, get somebody from your team. And so that also happens. So it's a mix of both, but mostly it depends on what area it is. And that's the answer to it.
So does that ever give you the problem where you might want to recruit someone for your central data team, but someone say volunteers their people as well? So are you sometimes committed to using their people instead of your own?
And so it's not their people, it's their budget that we get. So we get given their budget, and so we can hire our own people. So that's how it.
Okay. And how many people, how many staff do you have in your data area?
So different companies. So for example, at the Iconic, there are 24, 25 people working in data. Across the group, across all the 17 countries, we have 132 people working in data. We have 4 different data groups in 9 different countries. And we also have 3 data teams sitting for a group function centrally located in 5 other countries. So totally, we have around 132 people working in different areas in data.
Okay. What do you do if you have, say, conflicting data or not up to date or missing customer data?
Yep. So one part of our data maturity map is also to have quality of data being assessed. So the integrity of data continuously keeps coming up. So I'll give you an example. Right? We solve it in 2 ways. One is we try to self-help ourselves, which is, for example, a lot of times when customers sign up, they don't have to give us their gender. So we don't collect gender information for customers. And so almost 40% of the customers don't give us a gender. So we say we don't have this data, or we would try to help ourselves by building an algorithm that can infer the gender based on everything that the customer does. So if she uses an iPhone and if she shops on these things, then she's she could be a female customer, and it could be a male customer. So that's one way we do it. And the other way we definitely do it is we do go out and talk to our customers, send out surveys, ask them for more information, encourage them, do customer focus groups, and then we try to backfill information based on the small set of people that we've done. So that's a mix of two things that we do.
Okay, yeah. Okay, so I think that's all we've got time for today. So we will send out the recording if you send us your email address, and perhaps we'll go back to so thank you very much, Kshira. We really appreciate your time in doing this, and particularly, and hopefully we'll have a physical event as well in the future and get you to come along again and tell us a bit more. That would be really good. But
Sure.
you might like to show us your screen again as to how people can engage with you and contact you and ask more questions. So that's great. So thank you very much, everyone, for joining, and stay safe, and hopefully when we get out of lockdown, I hope to see you all physically soon for a physical event. So that was great. Thank you very much for attending.
Thank you, Laura. Thank you very much for having me.
Thank you.
Appreciate it. Thank you. Bye.
Thank you. Bye.